Common Computer Private Limited e-learning program of IP addressing. We are going to see about IP addressing architecture and the subnet mask and a little bit about IP version 6 and what is the usage of IP version 4 and the requirement of IP version 6, how we match it with the OSI reference models and the technologies which are all used based on IP version 4. So let us go to the presentation. So internet architecture, computers are connected to the internet and they are communicating from one place to other place through a lot of internet links, connectivity devices like router, switches, servers, and they are able to reach a defined destination as per the requirement. All these things because of the IP address. Whatever we follow as a number, we record it in the system, register for the system so that I'm able to reach the specified destination mission from anywhere, any part of the world. So this is also applicable for LAN, all the network architectures. Without IP address, we will not be able to communicate in the network, whether it is a LAN, MAN, WAN. So without IP address, we will not be able to communicate. So protocol, what is a protocol? So it is a standard used to define method of exchanging data over a computer network. So defined set of rules. So based on the ISO standardization and regularization, we have defined set of rules. This has to be used by programs for communicating. We call that as a protocol. So different types of protocols are available and they'll be following the rules for sending and receiving the data based on the requirement. This is used for describing how devices can communicate, in which layer, how it is. So they are defining the program. Also, this defines the format of data that is being exchanged. In what format it is being exchanged. For example, in OSI layer, it will be in the form of frame link layer 2, then packets, then segments in layer 4. So it gets changed. So this is being defined in the protocol standard. Definition of IP. IP stands for Internet Protocol. This is a layer 3 protocol and it works in conjunction with the layer 4 TCP protocol. So with the combination of TCP and IP only, we are able to communicate with other systems. So there are types of protocols available. One is connection oriented protocol, other is connectionless protocol. So connection oriented means if I'm sending the information, I'll wait for the acknowledgement from the recipient or the destination mission. Once I get the acknowledgement, then I will transfer the next packet. Till that time, I'll be holding the second packet of information. That is the connection oriented. Connectionless is whether I'm getting the acknowledgement or not, I'll keep on sending the information to the destination so that I can finish my job faster. So by that way, connection oriented protocol is a kind of slow communication and connectionless is a faster communication. So wherever it is required based on the requirement project design, we use this kind of protocols. Difference between IP address and MAC address. So IP address we are discussing now, which is a logical address, and this is assigned by the administrator in each computer or server or in the devices. So each device will be given IP address and that can be changed, right? So it is not a permanent one. This is a logical address. This is not a permanent address. And this follows a hierarchical format and it is a 32-bit or 4-byte of information splitted as a segments. Octet, we call it as a octet. And there is a possibility of duplication because if I go with a static allocation of IP address, there is a possibility I would have assigned a same IP address which is given for other server. So that is the chance available. So we go for a DHCP support so that server takes care of assigning the IP address to all the endpoints. So this is being assigned by system administrator or DHCP servers or by network administrator. So this is the logical kind of address and being managed by the administrator. MAC address, it is a physical address. It is 48-bit, 6 byte. It is unique address for each adapter. Based on the international standards, each manufacturer is given a prefix, and they'll be holding it, and based on the other rest of the 24 bits suffix, they'll be using the random numbers, and they'll manufacture network adapter. Across the globe, no duplication of MAC address. This is also called as burnt in address, because it is written while manufacturing the network card or motherboard or the network devices, so it is not separately written. And this cannot be overwritten by any kind of programs like operating system. Maybe while doing the firmware or factory reset, we can again burn the firmware to the particular device. Only by that we can do it. Otherwise, normal softwares cannot change the MAC address of the system. So this works in the layer 2 data link layer. It is a flat address. There is no hierarchy followed. That is directly 48-bit address. So it is done by the manufacturer, not by the company's administrator people, whether it is done by the manufacturers. Datagram. So what happens here is we have a data whenever it is being shipped to the next layer and all, it is getting added with the header information. So data with header information, we call it as a packet. So IP is a network layer protocol. It is working in layer 3, and it is communicating with multiple other protocols and other media in multiple layers, right? So being in layer 3, I have communication with the ICMP and IGMP protocol, and in layer 2 I have a connection to ARP protocol. Layer 4 I have connection with TCP and UDP protocol. So this is being working in the central place and supporting multiple protocols in the layer, OSI layer. So types of communication, we have unicast, multicast and broadcast communication. So if it is one-to-one, it is called as unicast. So one person is speaking to one person dedicatedly. One device is to one device. That is a unicast communication. One device to several devices, which is authorized or selected devices, it is called multicast. One device to multiple devices, right? All the devices may be in the crowd or in the network, it is called as a broadcast. So it differs three types of communication. So OSI reference model, we have a separate session provided for detailed discussion on OSI. But here, so we have 7 layers of OSI layer based on the ISO recommendations. These layer is defined. Each layer is owning the separate protocol, separate devices, supporting the operation dedicated to this particular devices. So here IP is falling under layer 3, TCP is falling under layer 4. So what is an IP address? So it is a unique global address for a network interface. Though it is a logical address, and it is also a unique address. We cannot repeat the same IP address over the network, right, for a company. So it should be unique for the company across the globe or across the network wherever it is available. Otherwise, within the organization, there will be a conflict. So once you get the conflict in IP address, either one of the device will not work, whether it is a server or network device. So there will be conflict in the communication. So it is very essential to ensure that there is no conflict for the IP address. So normally in the end user computing, so there will be issues with the IP address. So definitely any one of the user will get disconnected. So if that happens for server, what will happen? So definitely we will not be able to manage the servers or manage the network devices properly. So we should ensure there is no duplication of IP address. So it is a 32-bit identifier. 32 bits we divide into 4 segments. We call it as a octet with the 8 bits, 8 bits, 8 bits. We call it as a octet, like first octet, second octet, third octet, and fourth octet. So there are 4 octets available. So here this is being defined by the international agencies, which are all like Internic, RIPE, and APNIC. They are responsible for specific regions of world. So IP address, there are 5 classes available in the IP address. So we take the reference as 4 octets, and since it is a 8 bits, right, 2 power 8, it is 256. So the numbers will range from 0 to 255. So that is the starting of IP address will be 0 and ending will be 255. So total it is 256. But usable IP address is different, because I said starting IP, it means as per the number it will start with 0, but it cannot be used. So usable IP address will be a different range for different segments. So now we have defined uh, different classes by taking reference as a first octet. The numbers will range from first octet like this. So first octet we are taking, first portion we are taking. So for class A it will be from 0 to 126. 127 is specifically used as a loopback address, but that is also a class A address only. So 0 to 126 actually it should be mentioned. So 127 it's a separate thing, but it is also a class A address only. Class B will be 128 to 191, and class C will be 192 to 223. Class D will be 224 to 239. Class E will be 240 to 255. So here the numbers are given based on 2 powers 8, 2 power 7, 2 power 6. That number will come down. So based on that only this range is defined. So class A means first portion is the network ID, and the rest of the 3 portions will be called as a host ID. So first we are taking that numbers reference as a network ID. So whenever I see the IP address, I can easily find out whether it is a class A, B or C. We are using only 3 classes. Rest of the 2 classes we are not using. One is for research purpose and one is left unused. So we are using only 3 classes. So that first class A address will be, we are taking the numbers from 0 to 126. So any number can be placed, and here the 3 portions we are taking for host portion. So 2 power 24, that much host we can use it. Three octets, right? 3 to 8, 24. So 2 power 24 host we can have for one network, and in the same way 2 power 8, 256 or 255. So that much network we can have for a particular class A network. So based on the available portions, we are defining how much systems we can connect for a particular class of a network. So same way class B, we are taking 2 portions as a network portion and 2 portion as a host portion. Class C, first 3 portions will be network portion, last one portion will be host portion. So it is reverse numbers for class A. So now the number of networks available in class C will be 2 power 24. That much network I can have. Number of hosts per network will be 2 power 8 minus 1, right? So I can have 255 hosts per network, 255 IPs per network. So this defines, like, based on the network design or requirement, we can choose whether I can go with class A or B or C, so that I can manage the global network. So if it is an organization running across the globe, so we'll have to choose class A, so that you'll have more hosts, right? So lakhs and lakhs of computers to manage that. It is preferably to go for class A, and some people will go for class C also based on their size. So that's the point we discussed. In case of class A, so first octet will be used for network portion. Rest of the octets, 24 bits, will be used for host portion. And class B, so that's the explanation provided here. So it is equal, right? In case of class B, 16 bits for network portion and 16 bits for host portion, we can use it. So address range is provided here. So class A 126. So 127 we have to ignore, or we have to take it from the table, because that is called as a loopback address that is used for checking the connectivity of the remote system. So we will not be using it for allocating the IP address to the computer. So we'll stop with 126, right? So the range is given here. Subnets and subnetting. So if I have huge number of big size of network, then it is very difficult to find out the computer available in the network, as well as the system will go for broadcasting the information for identifying the destination computer. So to avoid that, what we are going to do, big network will be divided into a small network that is called a subnet. And the way we are going for calculating the subnet mask and dividing the IP address, we call it as a subnetting. So the benefit of this subnetting and dividing a small network is we are going to avoid the broadcast domain, a bigger broadcast domain. So it will be divided into smaller one. So identifying the network, it will be easy. So if at all I have one network with 10,000 machines, now what I'm going to do, I'll break it as a 10 network with 1000 machines each. So the lookup for a particular destination system will be easier and faster compared to the previous method. So that's the reason we go for subnetting concepts, as well as we can save the IP addresses. For based on the requirement, I can take a slash 25 26 something like that, and I need not go for slash 24 where most of the IP address will be wasted, unallocated. So that's the reason we are going for subnetting. So subnet mask is provided. So default subnet mask will be for class A, it will be 255, because it is working only first octet. We cover all the first octet portion. It is called as 255. So the full mask will be 255.0.0.0. In case of class B, it is 255.255.0.0. Class C, 255.255.255.0. Three 255 portions, because it is taking three portions as a network, one portion as a host. So all network portions will be marked as 255. The purpose of subnet mask, right? Why we have to go for subnet mask? So this is the one which is helping us to find out the network as well as host in the network. When I'm going for looking out, I said I have 10 networks and 1000 machines per network. So from first network to fourth network, I'm transferring the data. So how will it will happen? How will I find out the machine available which is available in fourth network? It can be in eighth network or 10th network also, right? So how can I find out within a short span of time, so that I can faster transfer the data and reduce the broadcast or collision inside the network. So what happens here is subnet mask plays a major role. What it does, first it is masking the host portion and trying to find out the network portion. If you take our scenario, we have 10 network with thousands of computer, 10,000 computers on the whole. So what I'm going to do, I'm not going to search for any host. So I'm going to search for the network. So what I'm doing, out of 10 network, I'm going to find out where is my network. So it is in the fourth queue. So I can just reach my network to the fourth network. I'll hold the search. Now I'm going to open the masking from host portion. I will mask the network portion because I know where is the network. So I will mask the network portion. Now the host portion is visible. It means I'm going to search within that particular net, thousands of mission. One mission I'm going to find out. So searching one mission out of 10,000 mission, and searching one mission out of 1000 mission, which you feel better, right? So here we are avoiding a huge amount of broadcast, huge amount of delay in identifying the mission and submitting the data to the mission. So that is how the subnet mask is working, and which is helping to speed up the communication. So IP version 123, we were not formally assigned. So directly we started using IP version 4 as a 32-bit address, and again IP version 5 we didn't utilized. It was used as an experimental one. Then we got IP version 6, which is 128-bit address, as a replacement for IP version 4, because we are growing on the computer, growing with the network, growing on the devices. So we have to go for IP version 6. So benefits of IP. So it is simple and familiar. It is widely supported. All the devices, right? All the type of devices, it is being supported with the IP address format. So PC, server, modem, router, printers. If you take any device that supports the IP address. So technologies, we have n number of technologies which is supporting the IP addresses. Whatever available in the market, the base is the IP address. Without IP address, you will not be able to communicate in the internet or intranet or any form of network portion. So why we need more IPs? So class A is 50% utilized, class C 12.5, class B 25%. So by now we are, this is the old statistics, but by now we have consumed all the other addresses, right? Because you take lot of IP based devices have come, and the technology is growing, and lot of service provider available, and with the internet services available, the mobile devices also increased. CCTV camera or IP based medical equipments, machineries, so it is keep on increasing. So that's the reason we have to provide IP address to all those equipments for providing the automation. They are connecting those machines with the computer, so it is consuming the IP address. So this is the reason why we have a shortage of IP version 4. So we started using classless domain routing, inter-domain routing, but that is not giving us big benefit. A smaller benefit anyhow we are getting it, and we also used NAT and PAT, so that I'm not using most of the public IP addresses. I'll restrict the number of public IP addresses. So NAT is network address translation, where I'm going to map multiple number of machines or group of machines into one public IP machine, so that I can save the public IP. These are all the methods I used for saving the version 4 public IP address. VLSM, the subnetting, right? Variable length subnet mask. So instead of wasting more number of IPs, if I want two IPs only, I will use /30. Four IPs only, I'll use /29, something like that. Subnetting calculation we did, and we come out with the minimum number of IPs required for establishing the communication. So for saving the IP address, these are all the methods we used. But still, though we have done a lot of efforts, still we need the IP addresses for growing network. So that's the reason we got IP version 6. So that is there in the market, and quite some time back we started using IP version 6 for all the equipments, and it is a 128-bit IP address. So still we have a lot of opportunity for utilizing the IP address. So it is totally new, and 128-bit means we are totally using the MAC address format, that is hexadecimal format we are using for representing the IP address for version 6. So possible addresses, I don't know how much is the value here. It is fully occupying the entire sheet of my presentation, so that much IPs I can use it. Now all the vendors who are all manufacturing the products that supports version 6, and it is also there with the operating system. So now if you take, I can find my IP version 4 address as well as IP version 6 in my computer. So it is, both are playing a common role, and it is kind of downward compatible, right? So I'm able to understand both IP version 4 as well as IP version 6 in my communication. So this is about IP version 4 and IP version 6. So now everywhere you see IP version 4 slowly coming down, and we are asked to use only IP version 6, right? So this is about the IP address. So we have come to the end of the topic. Thank you very much.